This lab can take advantage of the calculating power of Excel. If you prepare your Excel spreadsheet ahead of time, then once you have collected your data, you can put it in the appropriate cells and your calculations can be completed. This demonstrates how I set up Excel. I literally copied the tables from the lab write-up because I knew that once I filled my data tables, I could simply copy and paste the numbers right into each of these columns. Set up correctly, all calculations that are to be done are completed once the data is present. One of the calculations you are to complete is found in this column. You are to complete a proof using conservation of momentum and conservation of energy that leads to equations that can predict the final momentum of each object based on the initial conditions of the mass and velocity. Once you have completed that proof, the equation can be listed in each of these cells, referencing the appropriate initial condition cells. The equation will be different in form for each object. The proof that you are to complete might be done most easily using momentum as your variable rather than individual mass and velocity variables. The initial equations for momentum conservation and kinetic energy conservation look like this. You might then proceed using substitution, solving the momentum equation for one of the final momenta and substituting that equation into the energy equation. After that, one needs to collect like terms and solve for the final momentum that remains. Once you have found that final momentum equation for one of the objects, you can then substitute that expression into the momentum equation that was solved for the other object's final momentum to get an equation for the final momentum of the other. As with other proofs you have had to do, yes, you can find it on the internet. But if you do, make sure that what you find has all the steps of the proof, that you copy those steps in your calculations page, and that you provide a citation of the website where you found it. The kinetic energy column equations are all 1/2 mv squared all the way down, gathering data from the relevant cells for before the collision and after. After that, I have a column that will be the calculation of percent errors between the predicted final momentum of each object and the observed final momentum of each object, the momentum of both masses before the collision and after the collision, a percent difference between those two values. Remember, we use percent difference when we arrive at two values that should be similar, but neither would be considered the accepted value. The total energies of both objects before and after the collisions, and the percent difference value comparing these energies before and after the collision. In the case of the momentum sums, if one object has a negative momentum after the collision, this is taken care of by listing the sum of the momenta after the collision, since a negative number would be in that cell. The energies are simple sums as well, and there should be no negative kinetic energy values. For the two-dimensional collision, I did a similar thing. I copied the tables as it is in the write-up so that once I have filled my write-up data tables, I can copy and paste it directly into these cells, and any calculations that need to be done are completed immediately. There is not a final momentum prediction in this one. You will be tracking the kinetic energy of both objects individually before and after the collision, as well as momentum of both the vertical and horizontal directions before and after the collision. Once that data is input, then calculations that you are to complete include the total initial momentum in the horizontal direction and the total initial momentum in the vertical direction. These should be simple sums. The total initial momentum will be obtained by putting Pythagorean's theorem as an equation in the cells under that label to use those horizontal and vertical sums. The same will be true for the final momentum values in the horizontal and vertical directions. They should be simple sums in the equation in each of the cells so that if one of the cells referenced has a negative value in it, the sum will include that negative number. The total final momentum will again be determined by putting Pythagorean's theorem as an equation in the cells under that label. The percent difference column will be comparing the numerical values of the total, initial, and final momenta. Beyond that are columns for calculating the total initial kinetic energy, a simple sum of kinetic energy each object has before the collision, the total final kinetic energy, a simple sum of the kinetic energy each object has after the collision, and a percent difference value comparing those two. I use an alternative form of the equation of kinetic energy in the kinetic energy column. In this case, the kinetic energy is the square of the momentum divided by the product of 2 multiplied by the mass. You are free to use the standard form of the kinetic energy equation as well. In either case, make sure that you're pulling numbers from the correct columns. What you will submit for grading: your completed Word document should include your completed data tables and the questions answered. After that, you should have calculations pages that would include tables from Part 1 with percent error calculations between the predicted and observed final momentum, the total momentum before and after the collisions, the total kinetic energy values before and after the collisions, and percent difference values for comparing the total initial and final momentum and the total and initial final kinetic energy. If you use Excel, then copy the appropriate calculations table. You can then make these clearer using the grid drop-down menu found in the font section to put lines around each cell. For the second part, the same required calculations can follow this one. There should be example calculations using relevant equations and your data to demonstrate your knowledge of using these equations. And the proof should also be found on your calculations page.